Welcome to Land House. I'm Seth. Years ago, I had the idea that you could use the hydraulic ram pump to make micro hydropower, and I just used a treadmill motor with some... Anyway, that whole test did not work very well. So I'm back at it again, and this time I'm taking a different approach. So let me show you what I've got. I bought this little DC motor here, which I forget the specs on it. We'll go over that later. Actually, it has 12 volts. 3,500 RPMs, so we can try out that. And then I got one of these little tiny motors here. I think it also does 12 volt, but anyway, the idea is to start up the ram pump. I've got my storage tanks on top of the hill. It's 150 gallons, but I want to first see if the overflow can flow back downhill about 15 feet of drop and have enough pressure to run a tiny nozzle and maybe spin. I was thinking something like one of these, like a computer fan maybe. I don't know, see if it have enough to spin that and get some voltage. We may even just hook this straight up to I don't know, an LED or something and see if it has enough power to run that. So in this video, it's not going to be the actual video of making power from the ram pump. I just want to kind of walk around and get things going and bring you along, and you can kind of see my thoughts behind it, and hopefully I can release an official video of running some LEDs from the ram pump hydropower. If this idea of the overflow doesn't work, I have a whole series of videos coming up where I have purchased some crazy expensive clear PVC pipe with all of the fittings. I should have been more prepared. Here we go. So I bought also the clear fittings to make an auto U-siphon that would allow me to fill up the storage tanks up top here and then flush them all at once to run a motor to make power. Anyway, all that aside, let's go ahead and get started with this video and see if we can make some power out of hydro and ram pumps. After browsing my PVC parts bin, I have found two things. This one right here is a bit bigger and goes to a 1/2 inch thread. I think this is going to be our winner right here. I'm not even sure what size that is, but it is tiny. So garden hose will come into this side, we'll have an on-off valve, and then hopefully that jet is small enough that it will maintain the water overflow. I don't know, let's find out. Anyway, let's go outside and get to work here on this project. Step number one is going to be getting this ram pump up and running again. It ran for about 5 months this year, and then Hurricane Fred stopped it, and then a tree uprooted over here and kind of messed up the intake. It ran for a couple more weeks and then stopped again. So basically the ram pump, if you're not familiar with it, has 2 valves and a pressure tank. So water flows down this pipe, activates this valve, which sends a pressure wave into the second valve, accumulates pressure here. Pressure has to push down on the water, which pushes it uphill. And I'll show you later my storage tanks, but it's way up the house, past the house on the hill. So let's go figure out what is stopping this from working. I have a feeling it's simply just debris over the intake. So the drive pipe goes along the flume here, goes to this catchment basin right here, which helps to reduce some of the sand. And then this is a supply line from filters up here, and I'll show you what that looks like. It seems like we have plenty of water going into this bucket, but maybe there's just enough silt up top that it's stopping it. This old tree right here fell down and caused some issues, and then this other tree over here fell down and caused some issues. So let's just step over here. Yeah, see if we can get, yeah, I think that's the problem. The fall leaves have just stuck to the screen of the intake and they're causing some issues. So let me just pull this back real quick, get the leaves out of here, and the ram pump should be ready to go. Whew, this water is cold this time of year. It's been getting down to freezing at night. Okay, let's see what we're dealing with now. Definitely stirring up some stuff, so we've increased the output there. So this bucket acts as a silt catchment and an air separator. Let's see, that's pretty clean down there. Let's drain it out and just make sure there's no leaves or anything close to the intake of the drive pipe. I hope to do some cold weather ram pump testing this year. I've said that for years and never have, but I think this may be the year we actually get to it. Yeah, that all looks pretty clean. This ram pump has seen a lot of use here. I'm gonna hold this valve open to make sure there's no leaves or stuff stuck in here. Seems pretty good. So you can watch the water jump up and down here in the pressure tank. That means the water, when it goes down, is leaving out the delivery pipe. The water in the storage tanks was at half. I couldn't tell if it was half full or half empty. But, so it's gonna take about 4 hours for that to fill up. So in the meantime, let's go ahead and test down here, and we'll have at least, I don't know, 75 gallons or so to work with. Now I can already tell that this is gonna let too much water out. So we're gonna have to use like a pinhole to keep the amount of water coming out of the ram pump, but because that's a lot of water right there. Let's see, so let's just go ahead and get this little test underway. I've got two computer fans. This one is a 12 volt and a 0.15 amp, and this one 12 volts 0.5 amp, so that one can make a bit more. But I've got my multimeter. We'll just do an unloaded first and see what these will spin at. I forgot to push record, so let's do this again. I've got the 12 volt 0.15 amp computer fan hooked up to my multimeter with some alligator clips, and I'm gonna try to hold this so you can see it and hold the fan into the nozzle and probably get soaked once again. So let's go ahead and crank this up. Bring it in pretty close. So unloaded, I've got 170 millivolt right there. There's 240 millivolt. I just hooked up the other fan to the multimeter. This one seems to have a much steeper blade. So let's go ahead and see if it has any better results with getting some voltage here. All right, the steeper angle here, I'm getting up to 300. With this fan, it got up to about 300 millivolts, and with this one, it got up to about 280 millivolts. So not exactly the high voltage I was hoping for. Let's go ahead and hook up a DC light bulb straight to this and see if we get any kind of light out of it at all. I couldn't find my LEDs, so let's see if we can get this tiny little motor to spin right here, just hooking it up directly to the red and black wires. Okay, I've simply got this little motor attached directly to the fan. We'll see if it'll spin it. It's about to rain, so I have to hurry up out here. Here we go. These two 12 volt fans that are producing somewhere between 2 and 300 millivolt is not enough power to run a 12 volt motor as I was expecting. So let me find out what the potential is here at this. Let's say it's just passing 1 gallon a minute. I'm not entirely certain what it is, but So for microhydro, it is gallons per minute, so 1 times the head pressure, which is approximately 15, divided by 10 is 1.5 watts is what this is able to produce. So not very much based on the amount of water and the drop that I have. So to be able to effectively do microhydro, you would have to have either a lot more head pressure or a lot more water. This is just the very first video of me setting up and preparing to do some testing here with ram pump microhydro. So if you have a comment about all of this, please leave that down below, and maybe together we can build a system that will actually make a few watts and will power maybe a strip of LEDs. Thanks for watching, and I'll see you in the next video. Bye.